Hi, hello. Today we are going to discuss about the stack operations. In the stack operation, we are going to discuss about push operation. In the last class, we have seen the different operations on the stack. The different operations on the stack are push operation, pop operation, overflow, underflow, and size. In the last class, we have seen its definitions. But in today's class, we are going to concentrate on push operation and on its algorithm. How it works? First, we'll go with its definition. We'll try to understand what is push operation. Adding an item at top of the stack is known as push operation. So, what is push operation? Adding an item to the stack at the top position of the stack is known as push operation. Let us concentrate on its algorithm. We have its algorithm in 4 steps. We'll concentrate on first step. In the first step, here it is given, step 1, check for overflow. Before you add an element to the stack, the first process or our first job is to check whether the stack is full or not. If it is full, you cannot add any item because it has certain limit. Imagine if we are having a stack of 10 elements and now the top value is 9, then we can say the stack is full. For such stacks, you cannot add another value because it is already full. We are going to call it as overflow. When the stack is full, we are going to call it as overflow. So first we have to check whether stack is overflow or not. If it is overflow, we can't add any item. If there is some space, then we can add an item. So step 1, check for overflow. Come to the second step. If top is a variable, top equal to n minus 1. Here instead of size we have taken n, or n is nothing but size of a stack. What is n? N is a size of a stack. So if top equal to size minus 1, as I already said, if we have a stack of 10 values, then size minus 1 is going to be 9. If the top value is at size minus 1 or n minus 1, if it is true, then in the next step we are going to say print stack is full or overflow, and from there only we have to exit. That means you cannot add. If it is false, then you come to the second step, that is top equal to top plus 1. Okay, we'll go to the next screen. We'll see the items here first. Okay, first you try to concentrate. Here you are seeing some 6 blocks. Try to concentrate on the first block here. Okay, so in this first block, try to understand. So this is stack. Its value starts like stack of 0. We have stack of 1, stack of 2, stack of 3, stack of 4. Indicates that it has 5 values. The first value starts from 0. 0, 1, 2, 3, 4. All are empty. There is nothing because the top value is equal to minus 1. Here you have to concentrate. Top value is equal to minus 1. Then what happens now? If top value is equal to minus 1, the first step of the algorithm, in the step 1 of the algorithm, we are going to see here. We are going to see step 1 of the algorithm. We are going to see check whether stack is full or not. Now top is equal to minus 1 indicates that stack is empty. That means obviously I can add items to the stack. So what happens here? In the second step, you are seeing top equal to top plus 1. Top equal to top plus 1. That means we are going to increment the top variable value by 1. And after that, just to concentrate on third step also. In the third step, stack of top equal to item. We can add any item. That item value depends on the user. You can add any value from the command prompt, and that value will be stored at the stack of the top. Okay, we'll see here. So in the first block, we have seen the top equal to -1. That means stack is empty according to the first step of the algorithm. We'll go to the second step of the algorithm, that is increment the top value by 1. What happens? The top value, top equal to -1, -1 plus equal to 0. Now top becomes 0, and in the third step of the algorithm you have said stack of 0. See here this step is very important. Stack of 0 is equal to item. I have pushed here 8 when top equal to 0. When top equal to 0. So you have added first element to the stack. You come back to the algorithm again. You see here the fourth step you have given here, return. Return means again you have to go back to input the second element. So it's not mandatory that you have to add all the elements at a time. It depends on the user need. If he wants to continue, he can continue again from the first step. What happens? Again in the first step, remember you are going to check whether stack is full or not. And in the second step, if it is not full, if the if condition goes false, then you are going to increment the top value by 1. Correct. After incrementing, you are inputting to the stack. And fourth step, you are returning. Remember, there is 4 simple steps. First step, check for overflow. Second step, if there is no overflow, if condition goes false, then increment the top value by 1, and then at the top position you have to input the item in the third step of the algorithm. Okay, we'll see here. We have inputted one value already. We have inputted one value when top equal to 0. Just remember the algorithm. Go for the first step, because each time you have to start the algorithm. In the step 1, you are going to check whether the stack is overflow or not. No, because now top value is equal to 0. When top equal to 0, if it has to be full, that means top equal to 4. If the top value becomes 4, then it says overflow, because of this is a stack of 5 values. 4 will be the last value, isn't it? Now what is top value? 0. That means you can add, obviously you can add one value to the stack, then increment the stack. What happens? The top value becomes top equal to top plus 1. Top equal to top plus 1 means top value is already 0, and the 0 plus 1 becomes how much here? 1. And in a stack of 1, you are going to input one more value. It is 5. I have given here, isn't it? See, in the stack 1, stack of 1, this line, this is stack of 1. Now we'll go for another step. Again we are going to return, and again we are going to start this algorithm. Okay, see, check for overflow, increment the, in the second step increment the top value, in the third step input the item, fourth step return. If it is full, then in the first step only you are going to exit. Okay, so let us see what happens. Okay, now in the here where we want to push 7, you can observe here the title is given here. We want to push 7 at the position 2. First we will check here step 1 of the algorithm, check for overflow. What is top value? Top value is going to be 1. That means it's not overflow. Then go to the second step of the algorithm. What is there in the second step of the algorithm? Top equal to top plus 1. Then what happens? The top value will be incremented to 2, because previously its value is 1. 1 plus 1 equal to 2. Now the top value becomes 2. Then what happens now? Stack of top equal to item. Stack of top equal to item. So stack of top equal to item means what happens here? We have inputted 7. So this is at second position. Okay. Similarly, again we'll return here and we'll check the algorithm. Same algorithm, we are repeating it. Step 1, check for overflow. Second step, increment the top. Third step, input the item. Fourth step, return. Okay, we'll come here. Check for overflow. There is no overflow here now because top value is 2. When top value is 2, then what you have to do? You have to increment the value. Now top value becomes what? 3. Now top value becomes 3. Then you input one more value. What value you inputted here? It's 4. So we have added 4 items to the stack. Now in the next step, we'll try to input one more element, that is 9, at the 5th position of the stack. Now what happens here? We'll check for the overflow. Now top value is 3. If top value is 3, then we are going to say top equal to top plus 1, then top becomes 4. At stack of top, that means stack of 4 equal to how much we are going to input here? 9. So these are the values we have inputted, or we have added, or we have pushed into the stack. The first value is 8, then the second value is 5, then the third value is 7, then the fourth value is 4, and the fifth value is 9. In the next step, what happens here? This is very important. In the next step, when we try to add an element, now it checks for the top value. What is top value? Top value is equal to 4 now. Hence size minus 1. Can you concentrate here? In this step, if top equal to n minus 1, that is size minus 1. Size is 5. 5 minus 1 is equal to 4. Yes, now it is 4. Then what message you are going to get here? At the last, stack is overflow or stack is full. This is how we are going to push an elements into the items. Now let me revise it one more time. Here you are seeing 6 blocks. First concentrate on the first block. The first block is empty when top equal to minus 1. That means the stack is empty. Increment the top value by 1, then top goes to 0, and we have pushed here 8. Then we have added one more value to the top, then the top becomes 1. Then we have pushed here 5. And then we incremented the value of top by again 1. The top value becomes 2, and we have pushed here 7. And then we have added one more value to the top, then the top becomes 3, and we have pushed here 4. Again we have incremented the top value by 1, the top becomes 4, and we have added here one more value called as 9. This is how we are going to push items into the stack. So next class I am going to take on pop operation. Thank you.